Hi, I'm Andy. I'm one of the lecturers down at Unitec in Auckland, and I teach automotive. So we cover pretty much cars, we do some motorcycle work and other bits and pieces for the students, and it's a one-year course. And I've just finished teaching for this year, and I've got basically the summer holidays where I like to produce as many videos as I can that cover the course content that we teach each year. And one of the areas that we cover is charging systems on vehicles. That's essentially the alternator and the charging circuit on the vehicle. We also cover batteries, how to test them, to look for problems and so on. We've got a little black RAV4 in today, similar to the one we did the CV boot on. And I want to do some investigation work and see if there are any problems on the charging circuit, and if so, where those faults are, and see if we can get them sorted out. So here we go. Okay, so under your bonnet, for those of you that don't yet know, you've got in the corner here the famous battery, which you often get accused of failing when there's actually nothing wrong with them. And fortunately on this particular vehicle, the alternator is probably about the easiest thing to get to, which is just here. Now the alternator is responsible for producing a voltage, a charge, a current, to run the systems on the vehicle whilst the vehicle's in use. The battery is there to store energy, electrical energy, to start the car first thing when the engine's turned off, and to also act as an energy electrical reservoir. So if for some reason we turn on too many ancillaries, we've got the headlights on, we've got the heater on, we've got the rear window heater, we've got the boombox and the amp and whatever else stuff that you've put on your vehicle. If they're all turned on and they exceed the amount of current that the alternator can produce, and this one I think is a 50 amp hour alternator, so it can kick out about 50 amps. If we're going to be consuming more than 50 amps, then the additional amperage that we need to run all the systems is going to be coming from that battery. And if you continue to operate like that for a long period of time, obviously that battery is going to be draining down and eventually it will go flat. Now under those circumstances there are no faults with the system or with the car. We're just using too much electrical systems on the vehicle all at once. And some vehicles fortunately have got a volt gauge on the dashboard on the older vehicles, and the driver can see problems. One of the issues nowadays is a lot of drivers tend not to look at the gauges, or they don't understand what they mean. So anyway, that's basically the scenario. Often when cars don't start in the morning, or whenever the driver goes to use the car, it's the battery that gets accused of failing. The battery's flat, it must need a new one. And many people out there just go and buy a new battery as a first fix, put the new battery on. Obviously they come out of the store normally 70-80% charged, they put it on the vehicle, connect it up, and of course the engine's going to start. But you know, if there's no charge or little charge coming out of the alternator, then they're going to be in the same position again in a week, 2 weeks, that afternoon, depends how they use the car, and the battery again is going to be flat. Now obviously it's far better to actually inspect the charging system on the vehicle. That includes the battery and the alternator and all the wires in between, and find out really where the problem lies. It could be something as simple as a bad connection somewhere in the circuit. It could be a slipping drive belt on the pulley. It could be just a blown fuse. Some cars actually have a fuse within the alternator circuit. So if you try to draw too much current from the alternator, it blows the fuse. I know that we have a red MR2 that we use now and again. That has a 120 amp fuse on the alternator circuit. If that fuse blows, nothing wrong with the alternator, you're just not going to get any more output. So you need to know how to be able to check these circuits and to check for volt drops around the circuit. So the first thing we're going to do is we're going to look at what the output is for the alternator. Now to do that, we need to have the engine running because the alternator is going to be spinning up, and we want to put a bit of load on the alternator so we can see if it can perform under load. We'll do a no load test first, and then we'll do a load test, and we'll see how it changes its output in accordance to that. Once we've checked the alternator, then I'll move on to talking about the battery, and that will be in the second video. Okay. Okay, so you can see here, look, we've got the multimeter set to volts DC, and it's an auto scale, so it's picked up that we're running on between 10 and 20 volts. So you've got here now, it's connected to the battery. I've just used an old fly wire to connect the earth. OCV is 12.36 volts. Now, once we've done that, we're going to reconnect the battery. We're going to come over to the alternator. We're going to start the engine up, and we're going to do a no load test on the alternator output. And you'll find, if you look for the big thick wire that comes off your alternator, just here, look, usually there's a 10mm spanner size bolt on there. That's the output of the alternator, and we're going to be taking some readings from there using both the multimeter to get a voltage reading and also a clamp type ammeter, and I'll show you how to use one of those shortly. Okay, so the engine is now running, which is obviously driving the alternator. The alternator is producing a voltage, and we've connected up the multimeter. Now we've got the positive lead going on to the output of the alternator. It's only 12, 14 volts, you're not going to get engine touching that. Okay, and we've got the negative of the multimeter going down to earth. Now obviously anything on the engine block is connected to battery earth, so you don't need to go all the way back to battery earth. In actual fact, I'd rather you didn't for this test. I'd rather you did the test using either the alternator casing. You're going to get basically the same reading from that. You put it on there, look, alternator casing, there you go. And the reading we've got is 14.54 volts. Now, what we should be doing to get this test accurate is the engine should be at fast idle. Now, at the moment it's only at normal idle. The engine's warmed up, it's at operating temperature. So we're going to bring the revs up slightly and see if that changes the reading. Okay, so we can see that the reading didn't really change too much. It stayed around about 14.55 volts, which is a good output for the alternator. If we now do a load test, that was a no load test. There was no ancillaries turned on the vehicle. We can stick the headlights on, we can stick the heated rear window on, we can stick the interior heat on. Basically as much stuff as we can to pull down the voltage, to create a large load on the system. That's going to make the alternators work a lot harder, and that's where the fast idle test is really going to show a difference between the output voltage from normal idle, regular idle to fast idle, and you must be testing these at fast idle. Okay, I'll go and turn some stuff on there. Okay, so we've got headlights on, we've got the rear window demist heater thing on there, we've got the internal fan blower blowing away quite hard. Which has now meant that the voltage has dropped right down to 13.32. Now don't forget, the original OCV battery voltage was only 12.3 or thereabouts. So we've definitely got an improvement. It proves we're getting an output. That additional voltage is going to be coming from somewhere, and it's coming from the alternator. Now the engine's running at normal idle. If we bring the idle up to fast idle again, we should see a large improvement. We're looking for about 14.5 volts again. Okay, so we got just under 14.5. It was 14.4748, which is really good. That's giving us an indication through voltage that the alternator is able to provide sufficient charging to compensate for all those ancillaries being on. Now don't forget, the alternator is also running the ignition system, it's running the fuel injection system, it's running the emission system. There's all sorts of other systems as well as what you've just turned on, or I have in this case. So from a voltage perspective, the alternator is working really well, and there are no faults there. Okay, we're going to now put a clamp type ammeter onto the output wire of the alternator, so we can see how many amps the alternator is producing. We've done the voltage. We can't use this multimeter to do that because it can only cope with 20 amps maximum. Well, these alternators can be 50, 60, 70 on the big Range Rovers and stuff, up to 200 amps. So we need to use a different tool for doing that, to take those readings. If you had tried to use one of these, all you'll do is blow the internal fuse, which is not a good idea because you've got to take off parts putting one in, and they're a bit of a pain. So look after your meter. So, one clamp type ammeter. As you can see, there are no wires. Basically, we put it around the wire we want to tell how many amps are flowing through, and when we have current flowing down a wire, it creates a magnetic field around it, and the more amperage flowing down the wire, the stronger the magnetic field. And inside here, that magnetic field is picked up, it's measured, and from that it can calculate, the device can calculate how many amps are flowing. Very, very useful tool. You can get these now, a reasonable one, for about 150 bucks. Again, just like with your meters, don't buy cheap because they don't last 5 minutes. Okay, so we need to put this on the correct setting. We've got a number of different positions. Now remember, we're dealing with DC current. If it was a really old school alternator with the rectifier unit external to the alternator, then we'll have 3 wires coming out, which will all be carrying an AC current. And that's the case certainly on plenty of motorcycles. They have the regular rectifier unit as a combination unit, and that's mounted on the frame somewhere on the bike, and the actual generator produces an AC current output. Anyway, that's a different story altogether. I'm sure time for a different video. Here we've got an internal regulator alternator, which means that the output coming out of the alternator is going to be a DC current, and it's geared up basically to go straight to the battery and to be used in the loom to run the vehicle system. So we need DC, and we've got here, look, we've got off position, which is where it is now. We've got hertz, which is frequency, we don't want that. We've got resistance, temperature, we don't want that either. You can measure all sorts of things with this device. We've got 600 amps DC, 1000 amps DC, 600 amps AC, 1000 amps AC. Well, there's no way this alternator is going to produce 800 amps, so we'll use that scale. The 1000 amp one is too high. We need to be as accurate as possible. So I've chosen 600 amps DC, and then all we need to do now is clip this around the thick output wire. And I've got a reading then, I'll show it on the camera, but I've got a reading of 39 amps. Which is pretty good. Pretty good. If you think, bear in mind, this unit is going to be, the alternator is going to be able to produce, I think it's about 50 or a 60 amp hour alternator rated. So it's already producing well over half its maximum output, given the ancillaries we've got turned on. Now don't forget, again, we're going to have to bring the idle up to a fast idle to get a really accurate reading of its potential output. Okay, so fortunately on this particular device we've got a hold feature which allows us to basically capture the screen, and we were around about 56, 57 amps, which is pretty much the maximum this alternator can produce. So what that tells me is that all the ancillaries that we've got, and we have the cooling fan fire up there as well, when the vehicle's at idle and the alternator's only being turned slowly, relatively slowly, it can only produce just short of 40 amps. Once we increase the engine RPM, the alternator then shot basically straight up to maximum output, which is telling me that what we're using within the ancillaries on the vehicle, or all the systems are using as regards an amperage, is greater than the output of the alternator. We're actually, whilst the engine's idling like this, we're actually drawing an amperage from the battery. We're starting to consume the charge within the battery in order to run the ancillaries on the system, because we've got too much stuff turned on. So as soon as we rev the engine, i.e. you set off from the traffic light so you get back on the motorway, the alternator is then increasing the speed, and it's kicking out more amps to then recharge the battery up. Okay, so a bit of a close-up for you now. We've got the clamp on ammeter, inductive ammeter, showing at normal idle around about 44 amps. And if we just give, or if I just give the engine a little bit of a rev, you'll see that increase. It should increase. There you go. That's excellent. Okay, so the alternator looked around about 70 amp hour. It should tell us maybe on the little sticker on there, look. I'll have a look at that later on. Can we focus? No, we can't. There we go. Okay. So the alternator's maximum output, it's kicking out 70 amps. Now the reason why it shot up to 70 is the cooling fan on the radiator just fired up, which obviously uses maybe another 10 or 15 amps of current. So the alternator was working extremely hard to give that kind of output. Okay, so we've done on this short video, and I'm trying to keep them short and bite-sized. We've tested the battery's OCV voltage by disconnecting the earth wire. We have checked the output from the alternator using a voltmeter set to DC volts. We have done the readings we took using that was at idle and at fast idle, and we were looking for, sorry, under load as well, and we were looking for an output voltage around about 14.5 volts DC. That's an indication that the alternator is able to produce a good output. I then turned on as many ancillaries onto the vehicle as I could to really put a large load onto the alternator, make it work hard. And again, at normal idle, it was only about 13.5 volts, which is a little bit low to what we want, but quite fine at idle. When we go to a fast idle, we see that then climb up to 14.5 or back to 14.5 volts, which is telling us the alternator is working hard and it's able to provide sufficient current to compensate for all the ancillary systems that we're using on the vehicle. So from these tests that we've done, the alternator itself is in very good order and working just as the manufacturer intended it to be. On my next video, we're going to do a circuit check for the charging system. So we've done the battery, we've done the alternator, we're going to do basically everything in between, which is all the wires. And that quick volt drop test will give us an indication on the condition of the wiring that forms that circuit. You know, are there any points of high resistance, any corrosion, any loose connections, that's going to reduce the output voltage going into the battery to charge the battery. Okay, my name is Andy Young and I'm one of the lecturers down at Unitec in Auckland, New Zealand, and I do find that producing these videos for my students is really helpful for them to learn what needs to be done in the workshops and whilst they're doing their tasks on campus. And I see no reason why I shouldn't share these videos with you, and hopefully you'll have found this video helpful when trying to diagnose a charging stroke battery fault that you may have on your car. These kind of faults are extremely common on vehicles. You hear every day somebody's got a flat battery on their car, and it's really useful to be able to diagnose where that problem is. And what we've just done on this video is just one of the diagnostics. We've checked the battery. We're going to check batteries in more detail on one of the other videos, so find that as well, have a look at that. And we've checked the output from the alternator. So we know that the alternator is in good order. There will be other videos that cover how alternators work and the internals and how to test each individual component of the internals on the alternators. So again, just search out that video. It's going to be on YouTube somewhere. Just search Andy Mechanic alternator and it's going to come up. Okay, so I'm going to sign off on this one, have a coffee, and then I'll come back and we'll do the volt drop test around the charging circuit. Thanks for watching. Cheers.